Hi, good afternoon, good evening, good morning, wherever you are. I'm Paul Wheels, founder of IoT North. Great to have you with us. We've got Olivier Bloch joining us from Azure with John Stavely, my good friend and helpful organizer for the event, who I'll be bringing in very soon. First of all, let me just give you a couple of messages in regards to IoT North. So we're looking to help you and expand and share that value with IoT. So please do check out the IoT North Marketplace on iotnorth.uk/marketplace. Register your use cases, share your value proposition, and we will market them and find you customers. And it's completely free. We've also got the IoT North Forum. So that's for anybody wanting to learn about IoT, share about IoT, support, educate, create topics. It's a place for you there. It's an open source forum for you to leverage and join us with us. And I'm going to bring Olivier and John in. Hi, guys. How are you doing?
Hey, Paul, how are you?
I'm good. I'm really looking forward to this call. We were just having a great chat there about the differentiations and the breakdowns of Edge, and your talk is sounding absolutely fantastic. Hey, John, what are you looking forward to hearing about?
Finding out more about IoT Edge, and I've seen some of the IoT Hub offerings that Microsoft use, interacting with Raspberry Pi predominantly, and it'd be really interesting to see how that's extended, and I felt the power about how they do simplify things. So I hope Olivier will be clarifying more of that for us.
Sure do. Me too. Olivier, great to see you. Would you like to just introduce yourself and tell us about your role there at Microsoft and Azure?
Yeah, definitely. And well, happy to answer all the questions that you have anytime, John. So feel free to interrupt me. So I'm Olivier Bloch. I'm working at Microsoft. I've been with Microsoft for 15 years. Actually, just celebrated the 15 years a couple of days ago.
Congratulations.
So I'm up for my big 15 years crystal here. So I've been at Microsoft for 15 years. Before that, I used to be an engineer in the field working on real-time systems. So I was developing things for telematics, for printers and things like that. And started my job at Microsoft as a developer evangelist for Windows Embedded. So talking about embedded devices to developers. Evolved in the company, from evangelist to program manager. Did a couple of years with Microsoft, or 3 years actually, with Microsoft Open Technologies, talking about open source, open standards, working with the communities. And I've been with the Azure IoT team since its inception 5 years ago. Joined the team, we're 25 devs and PM. We're about 600 now, and we are working on different types of services to allow our customers connecting the devices and doing more. And we'll talk about some of that today. And my role today is to work with communities. I'm in a team in charge of developer experience. Mm-hmm. And I'm here with we're a team of two, with Benjamin Cabé, my partner in crime, to discuss with developers, on different topics. One of them is how we can help simplifying IoT that has become pretty complex, and that we ought, I think, as a company, to help our customers getting through and simplifying, uncomplicating. So that's one of the things I'm doing, talking to you guys.
Cool, that's really great. I mean, it's one of the things that I'm a huge advocate of is the whole developer relations side of things, empowering the users to help the buyers make the right decisions with a share of communication, information, content, forums like we've created for the community here on the website as well. I was hoping one of our guys usually joins us and gives us a bit of an update on manufacturing. Mark, who I have shared the link with on LinkedIn. I was kind of hoping he would join the stream, but he's not going to get in time. So Olivier, rather than hang on and hold this up, he can always join on at the end. Hold on, as if by magic, Mark's arrived. Hi, Mark. How are you doing?
Hi, I'm good, thank you.
Good. Mark, I'm gonna put you on screen, and I'm gonna if you want to fire away with your update, that would be fantastic. No pressure.
So I've got a delay, so I'm going to go without the microphone. Okay, so a very short month, or so it felt to me. UK manufacturing is definitely recovering. It's definitely spring. So what have we seen over the month? Most notably, in the last couple of days, we've seen the highest purchasing managers index since 1994 at 60.9. We've seen 115,500 cars built in March 21. So the car industry is now coming back for the UK. And I mentioned the figure just to give a feel for how big a market it really is. We've seen traditional manufacturing like Saint-Germain Glassworks, Ibstock Brick committing to invest and therefore committing to invest in the latest technology. So you'll see high-end automation, Internet of Things, connectivity put into traditional manufacturing in inverted sense. We've seen just last week in my LinkedIn post on manufacturing, I talked about £150,000 of investment announced just within that week prior to the bank holiday. We've seen NatWest, PMI, various people announcing increased figures. We've seen R&D up by 4.8% announced during the month, and we've seen other big figures like food and bev. UK food and bev is still booming, employs 4 million people and £1.61 billion turnover, and a real leader in the use of technology in manufacturing. Wrapping things up, what have we seen? We've seen a lot of talk about investment into electric transportation, battery gigafactories. We've seen a lot of investment and good news announcements from bus companies. And finally, more seriously, a big push still in the defence budgets, the space industries, and manufacturing is very heavily in the spring of recovery and hopefully leading the UK economy out of this challenging past year and a half.
Great update as always, Mark. Thanks very much for that. I really appreciate it. And thanks for literally jumping straight in as you joined us. Olivier, I'm going to hand this over to you now. It's your show to demonstrate and do the live demo, which we're really looking forward to. Thanks now.
Thank you. And thanks all for joining today. I hope it's more of a conversation, so feel free to interrupt Paul, John, everyone, and ask your question in the chat up there. I'll be more than happy to jump on your questions when I see them passing, or actually, I'm sure Paul will tell me when there are questions there. So
I sure will. Sorry, Olivier, that's one thing that I did forget to say. If anybody has any questions as Olivier is presenting, just put it in comments there, and we'll bring it up on screen live, and Olivier and ourselves will answer them. Thanks for that, Olivier.
Thanks, Paul. So the topic of today is about simplifying IoT, and I don't have any slides. So what I'm going to do is walk you through, my perspective as well as some demos that will allow to highlight this perspective of mine. And once again, you can agree, you can disagree, you can bring your own perspective as well to the conversation. I think that's one of the things I would like to extract from this meetup here is really hear from you. Whether you have experience with IoT, if you do, what kind of things are you facing as roadblocks, and how would you see and appreciate a set of toolings and technologies to help you get through all of that. And so the first thing I'd like to do in when I talk about simplifying IoT is kind of defining what IoT is to me. I think we all have our own definitions. It comes, from the fact that we all have a different angle when it comes to approaching IoT and IoT projects. IoT stands for Internet of Things, as I hope everyone knows. That's not the case. Well, Internet of Things. So it's about not just connecting the devices to the cloud to extract more insights from the data they can produce and then take action. It's not just that anymore. There's been an evolution of what IoT was about. Before we talked about IoT, by the way, we talked about smart devices. That was certainly like 15 years ago. We talked about making devices smarter. We already had a bunch of controllers and tiny microcontrollers as well in cars, in automation systems, and more and more in consumer as well. And these devices need to run software. And so we had a huge focus on real-time operating systems. We had a focus on bringing software with different languages and the tooling around it onto these devices. The step after that was to have these devices connected. The internet had been, growing really fast, and the notion of having devices intelligent was not enough anymore. Was about also harnessing the data and the sensors that were on these devices to be able to extend solutions with that data. And so we started connecting these devices. And now we're at the point where we go way beyond. So we were able to build these connected asset solutions, monitor remotely a set of assets, set of devices, check on their temperature, check on the status, check on, motion detection, trigger alerts and things like that. IoT now is part of a way broader story. From connected assets, we're moving to connected environments. It's no longer just about the IoT solution itself. It's about integrating that solution, that set of devices, their data into something bigger. Implement, smart data analytics on top. Work with business applications to trigger workflows, right? So if you see that an engine on some machine is about to fail because you analyze, its vibration data, for example, you want to trigger you want to create a ticket for a maintenance team to be dispatched and to preemptively, I don't know, act on that notification to go fix that engine, that machine before it fails. And that the integration with business application requires different types of engineers, actors, players to play part in your solutions. So not only are we moving from the type of solutions that IoT integrate into, and they're bigger and bigger, but also IoT applies to more and more domains, more and more disciplines. IoT comes in scenarios that not just imply automation. They sometimes imply things that are related to physics, to mechanics, to chemistry. And so as an engineer working on IoT solution, whether it's on the device side of things with the sensors and firmwares and so on, or if you now are a new type of IT developer working on the back end of the application and how you manage devices, how you collect the data, implement the analytics, you need to now work with different types of engineers. You need to interact with data scientists. You need to interact with mechanical engineers, with chemical engineers and other types of engineers, and you need to find a way to work around data together with a set of tools, with a set of technologies that make it easier. And so it goes into tooling. Simplifying IoT goes into tooling, goes into building the technologies that will glue these various worlds. The world of the devices, the world of the cloud, and the different disciplines and domains the applications are applied to. And so at Microsoft, we are building a bunch of products, but I'm not here to advertise the products. I'm going to just use some of them to highlight, how we can help simplify IoT. I'm fairly sure, and I know for a fact, that our competitors do have similar technologies and tools because they're in the same motion of trying to simplify IoT. And so when we look at a process for building an IoT solution, it goes all the way from prototyping, trying to validate a concept, an idea. I want to measure temperature there for verifying that my furnace is at the right temperature to start my glass melting process, so that I can actually get the right set of glass that are built from that furnace. And so you start from that idea of prototyping, and then what you want to do is go to a proof of concept, and then go to production. And at all these steps, you will need to have a set of tools that will help you do that in a more easy way. So let me actually jump into something which is interestingly for IoT. Usually we jump into the device side of things. So you'll see device, you'll see coding for devices, but what I would like to start with is the cloud side of the story. I would like to start with IoT Central, which is a good example of how we can help simplify IoT by making developing applications in the cloud a bit easier. So let me actually change screen here. And let me just show you my screen here, not the device yet. So IoT Central is an example of almost what we call a SaaS solution, software as a service solution. The idea here is to provide our customers with a ready-to-start solution, something that in a few clicks will get you started. And now, once you have that, you have a first proof of concept, and I'll build one real quick now, and then you can build around it. You can extend the solution, and I'll show you a couple of areas where you can do that. And so IoT Central is something you can go to, IoT, it's iotcentral.com, I think, something like that. You can find it pretty easily. And in there, you can start in several ways. Whether you kind of know what you're going to do, in which case you have a set of templates you can leverage, or you can also just build everything from scratch. So let me actually show you first one of the templates so that you realize what we're talking about here. So in the build, and once again, pretty easy to find. You need an Azure subscription, which, by the way, if you're not using any of the services, is free. So we ask your credit card for identification, but you can create an Azure subscription today if you want to. There's a trial as well. It gives you some credit to go try some services and some products. So I definitely urge you to go and try that if you have not done that yet. So then IoT Central comes as well with some free tiers and freebies. Was like very low cost for devices and for few devices, and solutions that are actually pre-populated with you with a bunch of functionalities and services. So let me go through one of the templates there. Let's say I want to build something which would be, for example, an in-store analytics solution. I'm going to monitor, let's say, whatever, doesn't matter, or smart inventory management. I've not tried that one. Let's see how it looks like. So the first step here is to define a name. It needs to be unique. It's going to be an endpoint, right? So you're going to have a way to provide access to a specific set of users. You will choose a name. You will choose a subscription you want to deploy that to. Let me pick one of my many subscriptions here, and I'll pick the one which is for my small demos. Let me see where it is. I can see it. Too many of them. I'll find it, and that's the one here. I don't want to deploy on some of my colleagues' solution. They will not like that. Let me pick United States. You see it's available in most regions, if not all. And then it's going to take a few minutes to deploy the application. And what deploying the application means is that it's actually deploying a bunch of services for you in the backend, a website that allows you to visualize the data from devices. And we have in the application a certain set of things that I want to walk you through real quick, just to give you an idea of the richness of that solution. So in the administration pane here, the first thing I want to drive you to is this notion of users and roles. The application IoT Central actually is backed up by a Active Directory instance that allows you to create new type of users, also do auth, across different types of authenticator services, and you can assign different types of role to users. And that means that in that application, some will have a builder role to create the application. Others will be operators, will be allowed to do certain amount of things, and then you have regular users will see part of the solution, part of the application. We also will have soon a notion of multiple customers, multiple users, to have some sort of a multi-tenancy support in IoT Central. You have API tokens that will allow you to use APIs from applications around IoT Central to interact with the app, and a bunch of other things here that I will definitely invite you to go look closer at what's going on in IoT Central to learn more about that. The idea in IoT Central is to define a set of templates. The templates are here to define the capabilities of a device, to allow for visualization of the data and interaction with the data from within the app and from the outside of the app. Once you have use the template like that, you have a pre-population of templates. This one actually is an inventory gateway. When you look at the capabilities it has, it actually supports some number of things in terms of properties, in terms of telemetry. It's all defined in that model over here. We'll talk about something that allows devices to auto-declare themselves to such applications. It's all based on the same concept here. But here you get it. So whether you start from a template, you have a set of device templates that are pre-populated for you, or you can create your own one by creating a new template, enriching a new one, changing the version, and so on. Once the devices are connected, you will start data to see data flowing in. One of the things that is super interesting as well is some of the devices can be simulated. So without doing a thing, actually, you're able, without having actual devices, based on the templates for these devices, a simulator will be created that will start sending data to your solution, so you can actually see what's going on. So here I can see in that BLE1 that I have a fake RFID tag, set of RFID tags or sending data, and I can see the data starting populating over here. The application then allows me to establish some rules, interact with all these devices as batch with jobs, do some analytics. I don't have much data in here, so you won't see much. Let me actually look at, for example, the BLE tags and their status. I don't know if I'm going to see anything in there. Let's do that. And let's see what do we have. Scanning interval, these are all the properties these things can do. But yeah, not the right one, I guess. Readers counts, maybe that one will be more interesting. And I will group by device ID analyze. So here I don't have much data, so I won't analyze much. But you can see here pretty rich analytics that is from within the application itself. Allows me to go dive into the past of the data, several days back, and then do a zoom in and so on. So not a good example, because here without data, you cannot analyze much, but you get the gist of it. You get the idea here. At a high level, I was able to get an application created and going pretty fast. So let me actually jump to a more custom application here, because you've seen something which is pre-populated, so not super interesting from the perspective of, hey, I want to create my own one. Well, let me jump into a empty app that I created earlier on. And here, when I say empty, this is basically what you get by default when you start IoT Central with no templates, right? So the thing is no device templates in there. There's no devices, nothing happening in there for now. So the first thing you will want to do is actually add device templates. You will eventually know what kind of devices you will have. So let's actually create a new device template. Here's the thing. If I know the device I will have, a good thing to do is to pick from a catalog, right? And so we have a catalog of devices that have been certified, and tested to work with Azure IoT services, and that will expose a model so that you can import a device template into IoT Central. Let me actually pick some of this, and the catalog is exposed in the IoT Central UI here, but you have way more on the website with instructions on how to find these models and how to import them. So let me, for example, pick a random one, because I don't have that right with me, which is still an interesting one, because that means that I will be able to still use that to create an application. Let me bring that template in. So that template is being published by a device manufacturer, and now I can see here I have a set of capabilities that are described for that type of device, with a set of sensors that are behind. I can define views as well in a template. That means that here you can see I can design with a WYSIWYG interface. I can design the look and feel of a dashboard, and I can create several dashboards as well, and several tabs for these dashboards. So that when I go to my devices list, I have a type of device, and for now you see there's nothing in there. And I'll be able to, when the device connects, identify itself as that type of device. It will actually start populating the application over here. In order to connect the device, you need to have credentials. Security is definitely part of the story here, using certificates or keys. And it's, once again, pretty much simplified for you here. Let me actually add a new device, and I'm going to use a simulated one using the default settings. And you can see here, new name has been assigned to it. And I can go into the different views that I was seeing in the previous views of the device template, and everything is down here now. It's been all created for you. So that's, at a high level, the gist of what we are talking about when it comes to simplifying IoT solutions development. Building a website that is able to display data is something that, at the end of the day, I think personally should be commodity. Having an interface for managing your devices, because here we're talking about just visualizing telemetry and so on. But as a matter of fact, you can see here there's a commands tab, and that commands tab allows you to send commands down to a device. I talked about jobs rapidly, but jobs actually will allow me to eventually implement a set of device updates or device configurations onto a set of devices at scale in production. So all that UI here that is provided is pretty rich, and will allow me to really build that OT side of my story without the need for any code, right? That's something that will make not just prototyping, but also building solutions pretty quick and fast. And so that's something that I think is definitely heading towards the right direction for simplifying IoT. So I was saying that IoT Central is something that you can extend. That's definitely the core of the story here. That's something that is implemented in a way that respects or follows what we've seen our customers doing. This is basically the generic aspects of an IoT core application. Securely connected devices, some visualization of the data, some level of analytics. I've not shown that, demonstrated that, but you can set up rules on telemetry to trigger alerts into different systems. What you want to do then is you want to be able to extend an application. The rule certainly is a good start. In these rules, you can eventually say, I want to set on a set of devices. I don't need to filter. You could filter based on the location of the device and so on. And then, oh, I see a question here. What software needs to be put on the device to link with IoT Central? Coming to that, it's a great question. So let me finish with the rules, and then we'll talk about the software needs to be put on the device. Actually, that's going to be the next part of the demo for sure. And here, let me actually select a telemetry. Let me do temperatures for a CPU, right? And eventually, I want to say if it's greater than a value, and I don't recall if this is Celsius or Fahrenheit or whatnot. So let's say it's over 100, right? I'm going to trigger an action when one of the devices has a temperature CPU reporting that is above 100 degrees. And I can do several things here. The integration can go to an external solution using webhooks, can send an email, and then you can use some of the Microsoft Azure services like Logic Apps, Power Automate, that actually will trigger an action in a workflow. And then you also have Azure Monitor action groups that you could integrate into a broader Azure solution to really monitor what's going on. So that's the rules. The jobs actually will allow you to batch these rules and these actions as well. So that's another way of looking at that. Last but not least, in terms of extensibility, is the data export. You can actually define a set of destination where you want your data to go. IoT Central can be used as the gateway for devices, and then this data that is actually collected by IoT Central or that you can interact with through IoT Central can be sent based on filters, based on rules, or in its entirety to different types of location for cold storage, for real-time or near real-time analytics, and so forth. So you can define destinations, export the data, and so on. So that's in a nutshell the super fast surf through IoT Central as an introduction. And the one thing that then comes is that super valid question: what do you need to have on the device side of things to connect to IoT Central or to an IoT application like that on Azure? So what powers IoT Central is a service called Azure IoT Hub. And the IoT Hub, let's say, is the building block that the building Lego block that is used in an IoT Central application. I will be using IoT Hub directly without an IoT Central application for the next one, but it's exactly the same principle. IoT Hub being behind IoT Central, this is what the device connects to. IoT Central enriches IoT Hub with a bunch of features in addition to the UI here. So on the device, what you need is a client that you will build based on our SDKs or on your own based on an MQTT client, for example. And that little client, that application, will establish a secure connection to your IoT Hub or IoT Central application with a hub underneath, using certs, using keys, and will then, once that connectivity is established, being able to communicate with the IoT Hub application. And we have a format that allows IoT Central application to understand what a device is saying. And the format actually is based on JSON and various ways of doing handshakes and so on. I will show you some of that. But how about we jump onto building a device that connects to an IoT Hub? And for that, I want to show you something which is very interesting and, to my opinion, pretty promising. And that's actually, that's not the simplest view here. That one is the simplest view. I have a little device over here, which that's this little guy here, which is from M5 Stack. It's an ESP32 based development board. What this little device here does, it has a bunch of sensors you can connect using Grove connectors, and you can develop for that device in various ways. One is using C code, another one is using MicroPython, and a third one is using graphical programming. And so for that, I have this interface called UI Flow. And the reason why I want to bring that in that conversation about simplifying IoT is because, especially for those who are not used to embedded or devices development, that can be a bit daunting, thinking about how I'm going to build in C first, or C++ for most of the devices out there. This is what you're going to use. And I'm going to deploy that application, make sure that it's easy to develop for that using debugging tools and so on. And then how will I make sure that I can monitor what's going on, establish the connectivity securely, put my secure seeds in some secure place on the device, and so on. And so when you look at all of that, you're a bit like, hey, how am I going to prototype first my ideas here? And here is an interesting approach to that, a no-code, low-code way of prototyping for devices. So I wanted to introduce that as a concept. It's not something Microsoft is developing. It's something that the M5 Stack company is developing, which is pretty interesting. The goal here is not to develop solutions using Blocky, which, as you'll see, is a graphical way of programming. The goal here is to allow for rapid prototyping of solutions, and then you can use the same hardware using tools dedicated for C and C++ development, and then flash actual C code that would actually extend the functionality from what you've been creating first with that prototyping tool. But let me actually real quick show you how that looks like and how you could, even if you're like 7 years old, create a prototype for IoT using this kit here. So the first thing I'm going to do is indicate to my application what kind of hardware I've been adding. So I have this sensor that I added to that device down here. So I'm going to add it to my application. I need to add some UI. In the UI here, I'm going to go simple. I'm just going to visualize temperature. Well, let me actually add a label here. I'm going to change the font so you can see what's going on. There you go. And I'm going to add a second label, and that second label will be the actual value, okay? So let me go for value 0 to start. The font's going to be this guy. And that's pretty much it, right? Now I'm going to build my application. And for most of the IoT application, the first thing you're going to create is a loop. So I'm going to repeat while something is actually true. So let me add some logic in there. And I'm going to add true here, right? So while it's true, what I want to do is I want to update that little label with the temperature read from that little sensor. So let's go and get the unit I connected here. And here I have get temperature, which is going to be that one block that allows me to grab the temperature. Then in my UI elements, I did add a label. And what I can do is on one of the labels, show a certain value. So on label 1, which is the little 0 here, I'm going to show that, which is get temperature. If I don't want to have things go a bit too crazy, what I want to do is add a timer, and I'm going to have to wait for 1 second, right? So here I created a loop. I created a label for the UI, and I implemented a loop, a way of displaying the temperature that is read from the sensor. So the device, as you can see down here, is connected to the internet. There's been a setup mode that allows me to flash the Wi-Fi information for my network here. And the device comes with what they call an API key. So it will ping to the M5 Stack backend and will say, and this is my device key, and now I want to connect to some tooling. And in the tooling, you will define what they call define the pairing with that device key in your account, in your application. So that way the backend knows where to send the code. Because here what I'm going to do, and you see the device is not connected to anything, I'm going to send my code to that device for it to run the code and start pulling the temperature data and displaying it. So that's pretty straightforward, not a single line of code. And I was able to extract data from a little sensor here and display that on the screen. But that's pretty cool and pretty neat here, because you can think about prototyping things pretty rapidly without a notion of what a device could look like. As a matter of fact, I did create one, a bit more complicated one, that connects to Azure IoT here. So the M5 Stack company, they created these blocks for different IoT cloud providers. What these blocks are, they are MQTT5 clients that have been actually wrapped so that you can add your secure authentication tokens in order to connect these devices to a cloud. And then they also added a couple of blocks that allow you to send telemetry in a format that respects the format that these clouds are expecting, so that it's pretty straightforward to then use. And here, what I'm using is a couple of properties that a couple of things that we're using in IoT Hub. One is called device twin. The other one is called telemetry. Telemetry is like I'm going to send data in a packet, which is my own format. And I like to format using JSON, so that way it's more readable in the backend, but I could do whatever I want here using IoT Hub. And then using device twins to synchronize properties. can you please share links to these applications? We'll do that for sure at some point. So search for M5 Stack. For the thing, UI Flow is the name of the tool that they have here, or M5 Flow, I think they renamed that. I'll be happy to share the links just after that, or when we enter into some more Q&A here. So here in my blocky code, I'm still doing the same kind of thing, retrieving temperature, humidity. I'm synchronizing a device twin, which is a JSON file that is synchronized between IoT Hub and the device itself when there's a change that happens. So that way you can set properties for the device and then have the device report properties back to the backend. So that mechanism actually is implemented in our SDKs or documented if you want to use an MQTT client to do that. I have an IoT Hub that I created an instance of. Here I'm using a tool called IoT Explorer that allows me to, as a developer, interact with my IoT Hub. I did create a device called M5 Go Olivier. And when I create a device on an IoT Hub, it gets credentials. It gets a primary, what we call connection string, that is basically a construction around an access key that's been generated over here. You could use X509 certs. I'm not using that right now. And so I've been using the connection string, copying that to populate my code here with that connection string that will actually allow this device to connect to Azure IoT Hub. Okay? Let me actually deploy that code here, and I'm going to walk you through the functionalities that are behind that. So pretty straightforward, once again, deploying the code from that device. The point here is not to show you how simple things are for deploying, because you've seen that already. What I would like to show you is a couple things. First is the telemetry and the way it comes up into the cloud. So when I receive the telemetry in the cloud, this is what I'm receiving from the IoT Hub service, right? This is the output of the cloud gateway. The output actually has a format with a header and then a body. And the header has some properties, allows me to identify when the message was received in the cloud. Eventually, it could be enriched here in that field with things that in the cloud, in IoT Hub, you can set up saying, hey, I'm receiving that temperature. I'm going to add a notion of like temperature has been exceeded, whatnot, doing analytics directly in IoT Hub so you can enrich the messages. And here you can see the body is a piece of JSON. And that piece of JSON, if I go back to my application here, I did create that here. So I did create that JSON with temperature indicating the value and humidity, and you see with the commas and quotes and so on, and the brackets, and that's pretty much it. Dump that into a JSON and sent that as a device to cloud message. Pretty straightforward. The second aspect of that communication is what we call the device twin. I want to show you what a device twin looks like. So once again, device twin is something that is synchronized between the cloud and the device to allow for synchronizing the state, a desired state and a reported state. The device here, has an amount of information that the cloud is aware of. And the device itself might not be aware of in terms of, the authentication and so on. Things are eventually stored in the cloud for you to identify the kind of device, how it will authenticate, and so on. What I want to bring your attention to is the section here with the properties. The properties is the core of device twin. One section is called desired, and the second one is called reported. So here, I don't report anything. I just have the metadata that should capture when there was a last update. So the device is not reporting properties, but what I'm doing is I'm using the desired properties to set up something on the device. And so on the device itself, what I'm doing is when I see a modification in that twin, I'm going to grab the desired properties, and I'm going to look the desired properties for RG and B, which are values for colors that I'm going to apply to the RGB LED strip that I have on the device itself. So see, the device is actually green here. If I go back to that device twin, I can see that this is the value that's been set previously. Let me switch that to red, the red only. I'm going to save that in the cloud, and it's going to actually be detected on the device that this change happened on that device twin, and will be applied down there on the device. So it's a nice way to configure a device remotely. How does it self-update, and how can it get updates or change configs for the devices remotely? So you've just seen here the use of device twin for changing configuration of a device. So that's interesting because you have a format, which is a device twin, that allows to push that desired state onto the device. And device code or receive a notification will look at the JSON payload and will apply the changes based on its own code. So you need to obviously implement the code down there. Other part of the question was about the update. So you have the setting up of a device, right? So you see here the bare bone aspects of how you set up a device. Telemetry goes up. There's also a way to send a command that has a timing in there. I'm not showing that, but it's a concept that would allow me to send a command to a device, assigning a timeout. The command can have parameters, and the device has to respond. So it's kind of the real-time interaction with the device versus the device twin, which is a state synchronization that happens, asynchronously. So when the device is connected, it will apply the whatever configuration is set in the twin. If it connects in an hour from now, it will pick it up in an hour and will apply it in an hour from now. Device method is something that, or direct method is something that allows you to do that directly. If you want to update the old software, the firmware of your device, we have a service to do that. This is something that is indeed complicated to do because every single device eventually has its own way of applying an update. Be it a full firmware, being just like portion. Am I using RAM? Am I using, like regular memory for that? So it's something that you need to have a level of implementation for that update on the device. However, we come with things that I would call the plumbing of device management within the Azure IoT services. One of the new features is called device update for IoT Hub. So imagine you have your IoT Hub, your device is connected to it. And what you can do then is you can use IoT Hub to dispatch a specific firmware to a set of your devices. And on the firmware itself, on the device itself, you would be notified of that device update request, and you would be able to go fetch the firmware. The device update infrastructure allows you to, hash proof the binary itself to make sure that you're running the right binary on the device, and then implement that flashing on the device, reboot, report on that version of firmware you have to the backend to know that the firmware has been applied, the update has been applied to the device. So we have a bunch of documentation and so on device update. I definitely would invite you to go take a look at that. So here we're saying that we're trying to simplify how devices communicate with the cloud. The other aspect that is really complex and complicated in these solutions that are growing is the integration of the device. Here you've seen device twin and device telemetry. There is here a way of defining, the format of the data, but it's something which is, by convention here. We're defining convention, the use of this JSON payload for synchronizing properties. We're using, this format for communicating envelopes with a payload, a telemetry payload, as well as the direct methods for cloud-to-device communication. But what's even more interesting is that at this stage with that, you still need to do lots of coding on the back end in order to understand a device, in order to display its data and interact with it. Like typically, you would have to know in advance of time that such and such type of telemetry will be coming from that device. And I gave you a glimpse of something called IoT Plug and Play in the IoT Central application previously. So let me go back in IoT Central here. Let me share my screen again. And I don't need the device for now, my bad. This is this one I'm looking for. So here in my previous, voyage into IoT Central, I would say, I manually added a device template. And that's something that actually has been defined, has been described by someone here. Someone did create a device template because he knew what the device was capable of. And what's interesting now is this notion of plug and play that will allow for device manufacturers to not just create models, but also tag them with an identifier, which is unique, and then allow for an application, a backend application, to pull the model from a repository based on that model ID. And that model is defined in a format that we call DTDL, which is Digital Twin Definition Language, which is based on JSON LD, basically, and defines not just the capability, but eventually the relationships between things, between devices. So in the case of plug and play for IoT Central and other Azure IoT services, we're using DTDL to define the capabilities of the device. So that means that you can, from an application perspective, receive a model ID from a device and populate your application with visuals, with graphics, on the data, because you know it's going to come in a specific format. So let me show you what that looks like, because here I did go through a new device template and so on. What I'm going to do now is I'm going to use the device connection settings here on a device, another one. Let me bring up that other device. Oh, not this one, this little one here. So I can pull this one and have a wire terminal here, which is an interesting device from Seed Studio. What I'm going to do with that device first is I'm going to set it up into a configuration mode. So let me actually plug it in. Let me push these 3 little buttons on top, and I'm in configuration mode here. Okay. So this little device here, I'll bring it up. I don't know if I can put something behind so that it shows a bit higher. Oh no, I'll try that. Problem with IoT, right, is you have to impro some of the demos. There you go. Not bad. Okay. The configuration mode here on my device. Let me switch to this guy here. And what I will show you here is the serial interface for that guy. Let me go to my minicom. Should be on the right COM port. And what I'm able to do here is to set up a connection. There's a firmware on that device that is IoT Hub capable in terms of connectivity, but also will allow me to send data in format that IoT Central will get in a plug and play format. And so what I'm going to do is I'm going to define the connection information for that device to be authenticated on IoT Central, and the firmware itself will notify the IoT Central application of its model ID, and the application will pull that model and then will populate automatically the user interface. What is there's a question from Charlie. What is the process for configuring data analysis, so spotting trends in the data, etc.? I will tackle that just after we have the plug and play thing going on. Thanks for the question up there, Charlie. And also, what about archiving? Can a sample rate be stipulated to keep an audit trail whether the other data is discarded? The answer is yes. You can definitely do that, and I'll talk about that real quick, because that's definitely something that you will want to learn about for sure. Let me here do a little command here to set up my device. And let me see the command. So it's going to be the ID scope, a key, and a device ID. So let me actually do a set AZ IoTC here. Let me go to my IoT Central application. And in here, I have a unique identifier for the application, which is that connection ID. What I want to do next is paste that here. I will use the SAS key, which is available in here. There's what we call an enrollment that define a specific key that devices can use to connect to the IoT Central application. Let me apply this here, and then we say it's going to be called, Wio Terminal Olivier. That's going to be the name, right? Connection has been sent to the device itself. So the firmware will grab that information and will use it in order to authenticate to the IoT Central application and then send its data. So what's the question from Stuart coming up? What's running on the device itself? So let me think, the Wio terminal, because I'm confusing my devices right now. Let me point you to the Wio terminal from Seed's webpage. I can tell you it's powered by FreeRTOS right now. In terms of the OS itself, and the code that's being used to program that is C code. And I can send you pointers for that firmware for the IoT Central application. It comes, as open source, and all you will be able to, go and leverage. It's using one of our C SDK that simplifies the way you will interact with device twins, with direct methods, with the provisioning service, and IoT Hub authentication mechanisms, and so on. So let me reboot the device right now that it is being configured specifically for this application, these IoT Central application. Let me switch back to the application, and here I'll go into my devices list. Device will connect to the Wi-Fi, and then connects to the provisioning service and connects to the IoT Hub, which is behind. And you see here in IoT Central, I'm receiving a notification that some updates are available, and I have this new device that came up, Wio Terminal Olivier. of a different type, of a new type. And actually, as a matter of fact, you can see here in my device templates, I have a new template that's been imported called the seed Wio terminal template. And my device, which is here, not only did it connect, but it also determined that it was that specific model, and the application pulled the model information and now constructed a UI that allows me to interact with that device. And here I have, the data will show up in a matter of like seconds. I can also send commands directly to it. Let me send for 1,000 milliseconds a little buzzer from the device. Let me put that on the microphone side of things here. Let's see if you heard that. Okay, hopefully you heard that. So the device actually received a command, understanding the command that the backend application was sending. Because of that IoT plug and play functionality, the backend knew how to send a command to the device in the right format. Actually, if I look at the device template and its capabilities, I should see a command in the list of properties here. So you can see I will receive acceleration, light intensity, and here I have a property, a command, which is called ring buzzer. And so that command here defines the fact that the device will support a direct method called ring buzzer with a certain parameter, and that this parameter actually, which is defined here, which is duration, will be an integer, and that will be used on the code on the device in order to ring the buzzer for a certain amount of time. So that's the way you would actually have plug and play in place. The device actually also is compatible with IoT plug and play, meaning that not only will it declare its model ID, but it will also implement the telemetry sending, the response to direct method, and the synchronization of a device twin accordingly, right? So there's that convention has been set and exposed through that model ID and model definition that both application and device now abide by, and now that contract is realized and the application can integrate very easily devices. And you can see here that I've been intentionally pulling in a device type that the application had no knowledge about initially, but it still was able to populate that application with the right set of visuals, of dashboards, as well as the right set of command support and so on. If I go back here, I should start seeing the data coming up and showing up. So we had a question from Charlie I want to address. Are you able to have the data stored and eventually filtered out, right? So you can implement analytics in order to filter it out. So you have different levels you can do that. If you're using IoT Hub directly, the underlying, you can actually configure Azure IoT Hub to push data to different types of storage and different types of services, whether you want to send to a regular blob storage, the whole entirety of the data, or if you want, you're able also to filter out some of that data. Let me actually eventually show you some of that. That's going to be easier. Let me go to the portal on another page here, and let's see if I can log in on that one. I will try and find my IoT Hub instance, and I will try and show you what's going on in there, because that's an interesting part of the process. And that's actually wrapped up in IoT Central in an interface that we call data export. So while I'm loading that other thing on the other page was the dual factor authentication. Let me validate that here. Sorry for that. Security approve, use my fingerprint. There you go. Sorry for that. So once the application is going to be up, I'll be able to show you that here. But in the meantime, let me show real quick, how could eventually create a destination in IT Central to actually define an export, a continuous export of all my data into for example, a blob storage. If I define a blob storage here, I will be able to indicate a connection string and a container that has been created somewhere else on Azure in order to point my application towards. And then let me cancel that for now. And then if I look at the exports, what I can do here is I can implement filtering on the data, doing some level of analytics on the data itself here in order to export part of the data. I can also enrich that data. Let's say, for example, I want to capture, telemetry for temperature only when it's above a certain threshold. I can define a filter. And then what on the telemetry data itself, I can eventually also implement a filter. I want only the temperature sensors are on floor 5, and that's defined as one of the properties in my device twin. So I can filter on that as well. And then I can enrich the data. I can say, I want to bring, for example, the firmware ID or number that is in my twin properties, and I want to bring that into the telemetry, so that way I can stamp the value of temperature with that information of the firmware number or version. So that way I can correlate eventually that there's an issue with that firmware because that temperature went up or something like that, right? So you can do all of that from within IoT Central to a certain extent in terms of what kind of filtering you can do. For now, it's kind of basic, but we're working on enriching to have very rich analytics using machine learning and so on that data. Now, if you want to do that, you can do that manually directly onto your infrastructure using the IoT Hub APIs, as well as some more services like Stream Analytics jobs and things like that on Azure, or machine learning algorithms as well. But the basics of that actually happens in IoT Hub, and this is the portal view for an IoT Hub instance. And in there, all the way down there, you will have something that allows you to, where is it actually? It's not that low. To create what we call the endpoints. So you'll be able to define specific endpoints that would be of the form of a storage account or an eventing service like Event Hub or Event Grid, and then define rules to implement analytics on the flow of data or on the properties of the device, pretty similar to what you've seen in IoT Central, and then send that data to the right endpoint, whether it's a storage account, whether it's an eventing service like Event Hub or Event Grid. So that's the gist of it. Obviously, way richer than that. What you can do as well is define, as we're saying, eventually an endpoint, which would be a Stream Analytics job, which is a real-time data analytics service, and implement your logic in that Stream Analytics job to then export part of the data or analyze data into another service, another storage, whatnot. Another approach is to leverage the time series insight service and push data to TSI to do, not just, long-term storage, cold storage, I would say, and then post-mortem analytics on that data, but also to do near real-time analytics directly into the time series insight tooling using the APIs or the service UI to go back in time and analyze all that data. So that's certainly one way of doing that as well. Or one more option is to deploy one of your favorite open source solution to do data analytics and push data from IoT Hub onto that service for it to do the filtering, to do the analytics the way you like and prefer, eventually leveraging your IP and the investments you've done in the past for analytics on data into that service. So definitely also an option deploying your own solution in the form of whether a VM or a microservice or whatnot, or a container as well, up on Azure. So that's definitely one way of doing that. Another way of doing that is to leverage IoT Edge, and that could be my segue. I know we're getting on time, but I really wanted to talk a little bit more as well about simplifying Intelligent Edge. So I don't know, Paul, if we have some more time, I can talk about Intelligent Edge, or if you guys prefer that I tackle some of the questions that came up that I went through really fast. And you're muted, the classic.
The classic mute. Am I on mute? It depends on how long you would need, mate. We can run over an extra 10 minutes or so.
Yeah, I can make it 10 minutes if people are interested to talk a little bit about, the Intelligent Edge and how we can simplify that as well, because it's complicated to bring the intelligence of the cloud to the edge. But I can keep it for another talk as well. Your call, guys.
Hey, let's keep it for another talk and get you on soon. This has been absolutely fantastic having you on. Yeah, I'd like to bring it, maybe do it a bit of a panel thing and have a couple of us chat about it. To be fair, let me bring John into the mix as well. There you go. I've unmuted you, John. Hey, let's bring in some of the questions there again. As
yes.
I've got a couple of things come up here. So you answered what was running on the device. There's lots of questions about what you were using. And links to those as well. So if we can share them and then we can get them sent out. Let's have a look. Why not syslogs into a CM?
That's a good question. And I will have to claim that I don't know what CM is. So maybe I should
clarify, Stuart, if you can mention in comments, that would be great. Can you point to a blog when finished about your AV broadcast setup, please? It's very good.
Actually, I have a blog already that talks about that.
I posted the link in YouTube, so it's in the comments in YouTube. And also, Olivier has a channel on YouTube as well, which is really good. And there's loads of material on there that people can watch.
Definitely, awesome. And so you can go check it out. That's something which is a Microsoft channel, and look for IoT Show, or go to aka.ms/IoT Show, and you'll find that video show there.
Excellent. John, I think we should definitely get Olivier back on again and show more. Absolutely brilliant. Okay, the clock's ticking. I think we've got all the questions answered there, and as John said, he put in the links in. Was it YouTube that you did that in, John?
Yes, in the comments on YouTube.
Okay, so if you check out the comments on YouTube, then that's great. Oh, here's Stuart's response. Security event management system use analytics once data is into the cloud.
Yes, so security-wise, there's like different aspects of it. So there's the connectivity first, right? Authentication of devices and so on. Everything when it comes to all the eventing, all the logging, and so on is managed on Azure, at the IoT Hub level and IoT Central level. It all feeds into Azure Monitor that allows you to really have a global view of your end-to-end solution. When it comes to deeper security management, we have a solution called Defender for IoT. The idea of Defender for IoT is to be able to, on both brownfield and greenfield, type of infrastructure, analyze the flow of data, analyze the events, and determine the risks that are detected, whether through reach analytics that we've implemented and capitalized on for years, as well as we made a recent acquisition of a company that actually specialized in devices and embedded devices security. And so Defender for IoT will be your end-to-end security monitoring, alerting, and so on, and feeds into Azure Monitor, which basically gives you, and Azure Central, which gives you that end-to-end monitoring of your end-to-end solutions, including the IoT part of the solution. When it comes to monitoring what's going on devices, you can have an agent model and an agentless model as well. The agentless model requires having a specific gateway that actually will analyze the data streams and so on in your network to detect the patterns that are known to be the ones at risk, and the one with an agent allows a device to connect to the Azure Defender for IoT service directly and report on even more things that are happening on it. So you can detect breaches, you can detect attacks and things like that. There's a very rich set of services that are provided, and once again actually ties into the topic of simplifying IoT. Security, I would say, should be a commodity, should be something that you don't have to think too much about. It should be there. And so we embed that in the core of our services and solutions when it comes to IoT and the rest. And that's why we integrate into the broader solution for security on Azure, so that your IoT system is not something in the corner. It's really integrated into the broader story here. But that's what, once again, that could be a 2 hours talk from someone even like more knowledgeable than me on the IoT security topic that I can point people to you guys.
It's certainly a hot topic at the moment as well, isn't it? There's an awful lot of big push socially about the importance of including security earlier on with your IoT. John, do you have any questions for Olivia?
So I've used IoT Hub. IoT Central seems to be sort of an abstraction on top of IoT Hub. Would you say that's fair?
Correct. That's a fair description of it. IoT Central uses and is based on IoT Hub plus other services. So under the hoods of IoT Central, which you don't have access to when you use IoT Central, right? You cannot go and play with the knobs of IoT Hub. You get the interface that is at a higher level, but it's combined with other services to give you that richness. So if you really need to have these knobs, you need to go with IoT Hub itself in a different solution where you're able to really go all the way down to the gist of what the devices will share as data and the way you control them, command them. IoT Central adds simplicity to developing your IoT application for sure. If that's not the way you want to handle that, go use IoT Hub, which is what powers IoT Central. Once again, actually, I didn't mention that, but one way that we believe we need to bring simplicity for IoT is to provide what people need as tools and as technologies. If you need the bare bone of an IoT cloud gateway for devices, IoT Hub is what you need. If you don't need to have the full UI and management features and analytics features of IoT Central, and you want to build your own ones, then use IoT Hub. That's exactly what it's for. And you did define it pretty well as being, a subset or a IoT Central being an abstraction on top of IoT Hub and other services.
Mm-hmm. Cool. Stuart also asked a question on pricing, and I have my own sort of angle on that, because usually with Azure, you get like a very basic free model where you just get, it's free forever and you can just play with it. But I noticed on the setup, it's free for 7 days and then it becomes chargeable. It's quite unusual for.
Yeah, so you have the model of like going with a free Azure subscription for the very first time, where you have 7 days of free and freebies in terms of credits for using across various services. So that's definitely the right thing. And then in terms of the pricing for IoT services per se, IoT Hub and IoT Central is very well documented. Actually, if you do a quick search, it's based on the number of devices as well as the data that is transferred. And it depends on the type of SKU you go with. So you will pick a different types of SKU depending on the volumes and number of devices you want to connect to pay for what you consume, basically. And so that's something which is deconstructed in terms of the pricing. So I can tell you it costs that much per device and per message, or per thousands or millions of messages, but it's written on our website. Actually, if I can try and find that real quick for you. And Azure IoT Central has also a free version when you stay under a certain number of messages per month with only 2 devices, right? With 1 or 2 devices, less than, I don't remember how many messages, you are free to use IoT Central. So if you want to use IoT Central for your home project with a couple of devices connected, you can try it out and you can play with it for free and forever. If you stay below that threshold of the number of messages. And then anyways, if you look at the pricing per message after that, it's in the ballpark of what our competitors are doing as well when it comes to the volumes. And so I would definitely urge you guys to go check out the pricing online.
Awesome.
Cool, thank you.
Excellent. Thanks. Mark, I'm going to bring you back into the stream as well, just to say the thank yous. Mark, as always, thanks very much for the monthly update in manufacturing. John, you made some support as always, buddy. I really appreciate it. And Olivia, thank you. That was absolutely brilliant. Just a couple of plugs in regards to IoT North, just to wrap it up. So we have the marketplace, which is available at iotnorth.uk/marketplace. You've built things. Let's get them out there, demonstrate the value. That's what we're trying to do. So putting in the value proposition is the key header there, focusing on the customer, the user. So please check that out on the website. We have the forum. Let's have a chat about the show today. What's your thoughts? Is there anything else we can help you with? Join the forum there. And that just leaves for me to say we've got a couple of things. Lots of thank yous from Brian Kelly. Thank you. Great session. Thanks, Brian. Totally agree. And again, from Stuart Smiles, who's had a number of questions. Thanks for engaging, Stuart. Really appreciate it. So thanks for that. And that just leaves me to say goodbye and play out the credits. Thanks, guys.
Oh, I don't even have an account.